So guys, today I'm going to solve this problem on max area of island. This is like one of the important graph problems which many FANG and many top companies in the industries are asking currently. So even like I'm new to this problem, like before this I solved a problem called find the total area, like total islands in the given 2D array. Now I'm going to try the same solution for this. This can be solved with either with both DFS or BFS. So now I'm going to tell you. Now let's take BFS way to solve it. Like I'll explain you the question first. There is a 2D array is given. It's like first row, second row, third row. In that, in between like the ones are the island and zeros are the sea oceans. Here we need to find the biggest island. See, continuous bigger. We can't consider the ones which are like diagonal. We can consider the ones which are vertical and horizontal. Okay, so here this is the biggest island. Six ones are together. Yeah, output is 6. We have to return the value 6 here. Okay. So let me try doing it right now. First, what we have to do is first we have to initialize rows and column for the. Okay, fine. First we'll take the row. Row is equal to length of the grid and column is equal to length of the grid of the zeroth array, first array. Because it's not n into n matrix, it's m into n matrix. So we'll take the first array. Now here, what we have to do is we have to initialize for or in. Before that, we have to store the already visited value in the set. Okay, we should not visit both, like we should not visit this one again and again. We have to visit this only one at one time. Okay, so that is the two. So here what we have to do to visit it equal to set for or in range of row for j in range of column. We have to define the BFS of first. Before that, max island. We'll just initialize like island is equal to BFS of r comma c. Yeah, sorry, by mistake I made as j, r comma c. Now max island is equal to max of island comma max island. So once we initialize it, we can return the max island, and we have to initialize the max island here is equal to, we initialize the 0 as of now. So now we'll write this BFS function. Okay, now what we are going to do in the BFS, it's like going to be a normal BFS with one extra function where this, if this node is 1, it has to look to the left side of it, right side of it, and down of it, and up of it. It has to look through all 4 of the directions. Okay, that this case we have to undertake here. So define BFS or comma C. Fine. First, what we will do is we have initialized the thing. Now we have to initialize the DQ. Okay, Q is equal to DQ. Q dot append R comma C while Q is equal R comma C is equal to Q dot pop left. We will pop the first element. Q means first in, first out. So we'll pop the first element. Yeah. What we will do is, what we have to do is we have to mention the island. Let's say island is equal to 0. We initialize it as 0. And here we need to append, since we need to appending two elements, we need to put two curly brackets, and we need to append, we need to add this in the visited set also, because this element can't be visited again. Okay, so why our row comma c is equal to pop dot left element. Now we are island is equal to plus equal to 1. Now we need to consider directions which it has to go. How many directions are there? 1, 0, minus 1 comma 0, 0 comma 1, 0 comma minus 1, all four directions. Okay, for direction of row and direction of column in direction, if 0 less than or equal to, here we'll just make it, yeah, we'll change rows calls. Here we make it like r is equal to dr plus rows, c is equal to dc plus calls 0 less than or less than or equal to rows, and 0 less than equal to c less than or equal to calls, and grid of r c equal to 1. It's not a string. And what is that one more initialization we have to do is we have to check whether r comma c not in visited. If it's there in visited, we can skip it. If r comma c is not in visited, then in this initialization we finally will be returning this islands. Initialization, what we do is visited dot add r comma c q dot append r comma c. So this overall thing will continue in a loop. To cross verify this answer, we'll try running this now. Hopefully it doesn't show any errors. Okay, it's not showing any error, but we have made some mistake. Plus equal to 1. Four directions we have mentioned. What we have to do is, what mistake I made is, like, here we have mentioned only R and C, so it gets confused with the BFS of R comma C. That's one of the error which we made. And another one is that here we need to initialize if grid of R of C in equal to 1 and R comma 0 comma column not in visited, then you can proceed with going to this BFS function. And what one of the base case we need to do, if not grid return 0. We'll try running it now. See, now all the test cases have been accepted. We'll submit it. Hopefully it doesn't show any time limit exceeded error. Okay guys, solution may not be the optimal solution, but still this is like one of the best solution is there. And now I'll explain you how you can transfer this to DFS. So what you have to do is, here we are doing pop left. Pop left, what does it do in the queue? It will take the first in, first out, take the first element of the queue and pops it out. Okay, instead of pop left, if you put pop, meaning what does pop do? Pop pops out the last element, last in, first out, which basically makes it as a stack. By changing this one simple thing, you can do this. Now let me give run. See, it's accepting. So by this changing this one thing, you consider making changing this old code to BFS to DFS. Thank you guys. That's it. Thanks for watching.